Hello, you beautiful lot. I need to get some key bindings set up for this so it's slightly more elegant. I'm just going to leave that running in the background nice and quietly there. Good evening. Hello. Welcome to my first dev stream. This is going to be a little different to the usual content that you see out there. I wanted to try and leverage the 2 and a bit decades of software experience I've had in the professional arena to try and give something back to people who are interested in learning it, essentially. So I'm going to work through a few different projects over time, and we're going to look at some different languages, some different frameworks, different tools and things you can use, some hacks and strategies that I've learned over the years that might be useful to you in your programming journey, essentially. And we're going to keep it nice and chill, is the plan. I'm also open to questions, so please ask anything that you like, programming related, in the chat. I say this, ask me what you like, within boundaries, of course. Yeah, so any coding questions you've got around what we're talking about, I'll be happy to try and answer as best I can, give you, or at least if I don't know the answer, I'll hopefully be able to point you in the right direction for where to look, essentially. And that isn't GPT-4. As useful as that can be for some development stuff. So what we're going to be starting with tonight is building a C#.NET 8 application. And what that means is that it's going to run cross-platform. So you can run it on Linux, on Windows, on Mac. Not on like your tumble dryer, or it's just going to be not going to be an IoT kind of thing. But yeah, so we're going to start with that. And it's not like a massive beginner course, so it's not even a course, is it? It's just me talking into the internet. But you know what I mean. It's not going to be like beginner. You're going to have to know a little bit of coding and know your way around stuff in order to get into this in some sort of death. But if you are new, then like I say, ask questions, and I'm very happy to answer. That is why I'm here. So I've got a bit of time this evening. I thought I'd do a live version of this. I will be following up with some recorded videos that will go out on YouTube as well, so you can catch up with those, and I'll put them in a playlist so you've got everything together and you can find it easy. So tonight we're going to be working on the first part of something that I'm going to call, or have called, Polygon. So the idea behind Polygon is that it's going to act as a framework or an accelerator to help you build applications in .NET 8 much more quickly. Eventually, we're going to wrap it up into a package, like a NuGet package or a GitHub package. We'll do both. We'll do both so you can see it. And then you'll be able to install that package in any application that you use going forwards, or you create going forwards. And you'll be able to plug it in, have all of the libraries and the classes and methods that we've built already, and you'll be able to implement those and use them to create a nice sort of quick development life cycle, I guess is the word. I am doing this live without script as well, so bear with me on my wordage, because sometimes the words don't come out like they're supposed to, and I'm just thinking a little bit. I tend to be a little pensive when I speak, so I'm not necessarily rambling things off very quickly. You get the vibe of this, I think. Hopefully you're going to get the vibe of this. It is going to be pretty chill. Just a nice little learning experience. So what I've done, I've got OBS set up, and you're only going to see the one monitor, and I'm going to do my damnedest not to dox myself by showing you stuff on my machine that I shouldn't be showing you. So I've already set everything up that you shouldn't see on screen number 2, which is over here, and you're going to be looking at screen number 1, which is here. So I've closed Pornhub and everything, so we won't catch any of that. That was a joke, obviously, but yeah. Let's have a look. Let's start. So I have created, I'm going to put the links to all of this stuff into the chat, and I'm going to put it into the video description comments as the description thing for the video as well. So you'll be able to see all the things that we're using to create the application. So we're going to start at the beginning, and we are going to talk about the tools that we're going to use and where the repository for the application is going to live. Okay, now I'm going to bring up the main monitor. There we are, and just turn that down a touch. There we go. Really need to get some key mappings done for that. Hit the transition button helps, doesn't it? There we are. Right, so we're on Google. Now I have created a repository for this in GitHub, which is public and contains nothing as of yet. Now I'm just going to grab that repository, and I'm going to slap it on the screen so you can see it. Make sure I don't give you anything that's going to make it crazy. But you can see that, like, this stuff you can see because it's just my professional crap, so that's fine. But I'm just going to... Where is it? There it is. So this link I'm going to throw onto the chat, but this is where you will find Polygon on GitHub. Now if I put that in the chat, you can see that in there. Bosh, there it is. Now you can grab that. You should be able to clone it, and if you haven't used GitHub before, you're going to need to create an account. I'm presuming as a developer or someone who's interested in development, you will have heard of GitHub and be familiar with the code repository stuff. But you can basically download it from here using HTTPS or the GitHub CLI. I don't think you could... Well, you might be able to use SSH if you've added a key to your private key server, but I'm not going to talk about that because that's a little bit out of scope of what I want to try and discuss this evening. So you can go there's nothing in the repo yet. There's a main branch, which is where what essentially would be the production code lives, and there is a develop branch, which is where we're going to be working. because we don't want development code going into the main branch, which should be for production. And that should be our mindset with Git. Always never commit directly into main, because main should be production. Any thoughts on that? Feel free. Razaman, hello buddy, thanks for joining this evening. So yes, the GitHub, so you can grab the code from that. There's a few other tools that you're going to need to use, and I'm just bringing the links up on here. So this is my screen you can't see, so I'm not going to show you anything, hopefully, that's going to wreck me by you mischievous bunch. Visual Studio, which again, if you are developers, I imagine, or into development, I imagine you will have heard of or hopefully used. You can download Visual Studio for free. There's a community edition which all of you can use, and has, in my experience, plenty of functionality for you to be able to sorry, I'm getting pop-ups on the other screen, but on this one, close that. There it is, look. Yeah, you can download Community Edition, which is going to give you everything you need to be able to build a .NET application. You can also use Visual Studio Code, which is a slightly lighter version, and as you can see, cross-platform, although there is a Mac version of Visual Studio that you can use as well. So you are, if you're on a Mac, you can use Visual Studio too. I use both of these. I use Visual Studio for the back-end development, which is all of your server-side code, and I use Visual Studio Code for the front-end development. So that's all of your user interface stuff. There's a lot of stuff out there now that requires compilation. It's not like the good old days back when you just used to write some HTML and CSS and your web page was just a big table. Yes, I have written websites as HTML tables, and I did that in 1998. So yeah, quite a while ago. We didn't have any fancy front end stuff back then at all. It was all CSS, and a lot of inline CSS, which looking back was utterly horrific, if I'm honest. So yeah, not grand. Excuse me, don't want to cough into the mic there. So yeah, grab yourself Visual Studio, grab yourself Visual Studio Code. Okay, so they're going to be your workhorses for this. Now, starting out, we aren't going to need any sort of database stuff because we're going to be building the application using an in-memory database, and I will explain a bit more about that as we get to it. So you haven't got to worry about SQL Server, setting up connection strings, any of that stuff. It's literally code it. The idea of a memory stream, an in-memory database, is, as the name suggests, it creates a database in the RAM, and it just disposes of it when the application is not running, not closes, when the application is no longer running. And it's really, really good for testing because you don't have to have any data. I would generally write like a seed method that populates the in-memory database with stuff that I'm going to need, and then yeah, just fire it up. And if you've got a development machine, decent amount of RAM, something like 16 gig, then that's gonna be fine. As long as you aren't seeding tons and tons of data into it, you're going to be absolutely fine. Another thing you're going to need, which is really important if you're going to use GitHub, is Git for Windows. So I'm going to put that in. Again, I'm expecting that you will probably have this if you are familiar with using Git in any sense. Git is a code repository management system invented by Linus Torvalds, who is the man who also is attributed to making Linux. So quite a smart guy there, really. And Git is, if you are old enough to remember Team Server or SVN, then you will appreciate how wonderful Git is when it's used properly. When it's not used properly, it's an absolute shit show. And I will do an episode talking about how to use Git properly, because it's really important. If you don't, you can make a mess fast. It requires an injection of energy to keep it in a good state. So yeah, but I'll talk about that in another episode. This is distraction. I'm going too far off the beaten path. So let's go back to Git for Windows quickly. So you want to download Git for Windows. Links in the chat there, and again I'll put that in the comments and description for the video. This enables you to use Git on your Windows machine, and I am very specifically talking Windows here. I can do Linux versions of the video. I could do an episode later on if people are interested around developing .NET applications in Linux, using Linux as a development environment. But yeah, if you want to see that, just hit me up and I'll put something together on that, because Linux is a really good development environment, and there's a lot of stuff that you can run natively that you have to do little workarounds sometimes in Windows 4. So highly recommend exploring it as an idea anyway for some development stuff. So next, what are we looking at next? So we've got coding environment. It's called an IDE, which is a Visual Studio and Visual Studio Code. We've got the repository. We've got Git that we need to have installed. I haven't got to worry about database or anything like that. We need to have the SDK, which should come with Visual Studio, but I'm going to show you anyway. .NET SDKs. Right, so we've got this. You are going to want to use .NET 8 long-term support, which basically means, as the name suggests, it is maintained and updated for longer. The pattern of these .NET versions, if you're not familiar with it, is that it's long-term support version, and then you'll get a standard term support, and then a long-term and a standard, as you can see on this page here. Okay. Currently, we're on version 8 long-term support. You're going to want to grab the SDK. The runtime is if you just want to run applications that have been built in .NET 8, and sometimes you'll see that if you try and install an application that's been built in a version of .NET that you don't have on your machine, it will prompt you to say this version is missing, and it will go and install it for you. So the runtime is what allows you to just run and execute the application. The SDK, or software development kit, is the bit that's going to let you do the building and the development stuff. So we're going to want the SDK on our machine. Now, I am x64. I presume that you've got an x64 machine. If you're using an ARM, good luck with that. But there's nothing wrong with ARM at all. It's just a different sort of chip architecture. But the x64 is generally the one that I'd go for. And just, yeah, download and install that as well. But I believe it comes with Visual Studio anyway, but just double check on that one. And here you go. You can see the end of support here is November 10th, 2026. So any applications you build in .NET 8, you will not need to update until before November the 10th, 2026. And I say before because I see this happen a lot. Well, not a lot, but I see it happen. People build applications in .NET or whatever bloody language, you know, PHP, Python, like anything, Symfony, whatever you're using. It is not great practice for it to get to like November the 11th, 2026, and for you to go, I need to update my application because it's gone out of date. Kind of want to be looking at that 6 months before, you know, thinking about it 6 months before. Now, with .NET, there generally aren't any massive changes in the way that it works, but you've still got to repoint your application to work for what I'm imagining will be .NET 10. Presumably they don't call it .NET X at that point, and then, you know, testing your application and doing the rollouts and release management and everything else that goes with it. So yeah, I'm dropping lots of bits in here, but it's just stuff that comes into my mind as I'm thinking. Right, what's next? What's next, caller? Now, I've got a proper gravelly throat this evening, and a fucked brain as well by the sounds of it. So yeah, bear with me a little bit. This evening, ladies and gentlemen, I'm going to power through anyway because I said I was going to do this tonight, and I'm going to damn well do it. Right, so that's enough looking at SDKs. So we've got Git, we've got IDE, we've got SDK for building. We've looked at the code repository very briefly. Right, now there's a number of different platforms you can use to manage your Git repository. You're going to make commits. You're going to commit code, and you're going to push it up to the repository when it's in a working state. You know, when you finish a feature, when you finish a bit of functionality, you want to commit the code, write a commit message, push it up into the repo. Okay. Now there are a number of different tools like GUIs that you can use to do that. If you're using GitHub, you have this one. GitHub Desktop is actually pretty good. I think it's built in Electron, but I could be wrong. So you can get GitHub Desktop. I'm going to slap that in the chat as well. So we've got GitHub Desktop, which is, yeah, if you're using GitHub, perfectly adequate tool. My personal favorite is one called Git Extensions, which I think uses Qt as the GUI, as the UI framework, but I could be wrong. I'm going to put that in chat as well. It looks a little bit basic, but I just like the functionality. I've used it for, you know, I'm comfortable with it. I've used it for years. I like it as a tool. So that's my go-to. I'll give you some more examples. So you've got GitKraken, which is a paid for one unless you're using public repositories. GitKraken's really good. I'll stick that in chat as well. So you got that. GitKraken's good. The free version's cool. You can use it on Polygon because it's a public repository. I don't know how much it is per year pricing wise if you're going to use it yourself. £4 a month. That's probably all you'd need if you're doing it for yourself. But yeah, again, it's got some really good tools. It's got a nice Git branch history graph and that kind of thing. Or there's like what's the Atlassian one? Git manager. What's it called? SourceTree. SourceTree's got a popular one, and that's free to use. Again, decent functionality. I'll stick that in the chat as well. It's worth having a look at. But yeah, just pick one that you like the look of and that resonates with you and that you can use. They all do fundamentally the same thing. I'm not going to talk about using Git terminal commands in this video because, again, that's probably something a bit more specialized that we'll go into in a separate one. And I need to make a note, actually, of all the different bits of content I'm going to put out for this stuff. So, that's all the things that we can talk about from a you know, software and build perspective. Let's get up Visual Studio. That's what we're going to be building our bad boy in. Now I have already. I might need to update this because I haven't. I've been using some. Yeah, I need to do an update. I've been doing some stuff in Rider and PHP Storm on some different languages lately, so I've not actually used Visual Studio for a couple of weeks. So it might take a minute just to fire itself up. So I want to open the repository that I've already got. Actually, I want to start a new project, don't I? Because I've already got the repo. So I presume you saw that file, and the logo's not in the way too much, hopefully, but file new project is what we want. And we want a C# as our language. And we are going to be building a .NET Core web app with Razor pages, because I'm going to introduce you to a little bit of Razor and how that works. Now, I'm going to start by, there's a couple of ways you can create a project, or you can segregate or partition a project up when you build it. Okay, let me go back to what I used to do and what I do now, and I'll explain why I've changed my angle a little bit. So I always used to have a number of different projects that were open inside a solution. So your solution is like your wrapper for many projects that can exist within it. And it's like a collection of projects that work towards the same end fundamentally. Now, I would always start with, if I was building a web application, I would start with a project that I will call core, and a project that I will call app or web, and that would be the web. So you'd have your web project would obviously be your web app, and the core would contain like your data layer, some of your business services and that kind of thing. Now, I've changed angle a little bit as I've got older. And I've actually become a little bit of an advocate of starting an application as a monolith. Now, what that means is that there's just one project, which is going to be our web app. And we're going to build it as a monolith because it's small and we want it all to just be contained in one project, one space. And we don't really know entirely what our application is going to look like yet. You know, we've got some ideas about some functionality that we want it to have. But rather than create loads of different projects at the beginning, when we don't entirely, when we haven't entirely thought out the architecture, for me, it's like getting ahead of yourself. So I tend to start, when I start at the very beginning, it's a monolithic application. As the application grows in complexity, we can look at separating out that monolith into distinct projects that serve a specific function. So you're going to have maybe a data project, yeah, that's going to handle all of your data stuff. Maybe you want to have an integration project that's going to handle all of your things like, you know, talking to stuff like SendGrid or PayPal and that kind of thing. But what we need to bear in mind with this is that the goal of this project, this application, is to create something that we can turn into a NuGet package, or maybe a series of NuGet packages, and then install those as like an accelerator for our .NET 8 projects going forwards. Which means we're going to want to have it as separate projects, because that's it, that project becomes the NuGet package. So let's say I've got 4 projects in my application. I've got a core project, I've got an integrations project that relies on the core, so there's a dependency there. Those projects are going to become their own individual NuGet packages that we can then install in other .NET applications if we want to use the functionality within those programs or those projects. But I don't want to do that yet because I'm not entirely sure what the functionality is going to be and how we're going to sort of put it together. But we can structure our monolith in such a way so that we know, you know, we put everything in well-named folders and we structure it intelligently and with some sort of thought and consideration. But let's not go wild yet. Let's not make loads of projects, because I've worked on plenty of solutions, and I'm sure you have as well, where you'll find a project in a solution that has like 2 classes in it. And you're like, well, why the fuck are there just 2 classes in this project? When those, and then you'll see that like those 2 classes has some overlap with classes that exist in a separate project, because, you know, different people have come in and worked on it over time, and it's like 3-4 years old, and, you know, 100 hands have touched it. It happens. It happens. It's development, you know. But as we're building this from the beginning, we're going to start with the monolith. So that's my monolith talk done. Talked about monoliths. You know, sadly not the 2001 style monolith where the, you know, the primordial man slaps the ground and goes wild in front of the giant computer. Polygon source. So this is going to be our source project, and we're going to call it Polygon. Now I'm going to have to type a bit funkily because I'm trying to work around the mic. I've not really thought this through very well. It's all right for gaming, but when I want to get in the middle, the mic cable's there. Project name is polygon.app. Let's call it polygon.app. That's going to be our web app, right? And then we're just going to have the solution is Polygon, because that's our sort of wrapper, our container for the different projects. All right. .NET 8. I don't want any authentication yet, because we're going to talk about that later. We're not going to enable Docker because I don't want to overcomplicate this at this stage. And top level statements, I'm going to leave that off as well. Do you know what? I need to check what that actually relates to, because I I can't remember, but I'm going to leave it turned off. Maybe you can correct me in chat. Help me out here a little bit. Right, so let's create our project. And select our repository. Great. So we're going to get a welcome thing here. Right. So this is our application as it comes out of the project template. So this root folder is where all of your sort of code, your front end code and everything else is going to live in the application. You're going to have a few standard pages that come out of the box with the template. App settings is where all of your config happens. That's as a JSON file in .NET Core, .NET 8, and then the program file is here. Now, if you have used .NET 6 before, then you'll probably know that there is no startup class anymore. Everything exists inside the program file now, and it's slightly different, but not much. You'll see we've got just a few basic initializers and service builders and stuff in there. Okay, so let's just have a little look. Let's hide that quickly. Let's have a little look at some stuff. Now, I'm just working off screen. I need to check something quickly. Like I said, this is not some fast-paced development class. This is just me sort of chatting through stuff a little bit. So bear with me. Chat amongst yourselves. Okay, let me just open something. I've got some stuff over here. Something I prepared earlier, which I just need to look at, which I'm going to put over here. Where is it putting that? In the downloads folder. All right, okay. Here we go. Here we go. And this is the... Yeah. All right. Okay. Now, we need to start thinking about the application in terms of what data is it going to be throwing around. That's how we want to start, right? All applications at some level are going to interact with data in some way. Yeah. This is where we're going to get onto our in-memory database stuff. Now, data is stored, or data is stored in applications, or referred to in applications as entities. So an entity is essentially a model that exists within a data set, or within data in some way. A model is a definition of an object. So that's going to have properties. It's going to contain properties in it, and we'll go into some of those as we start building this. Properties are going to be things like your strings, your booleans, your integers, all that sort of stuff. An entity is exactly the same as a model, except it exists within a data store somewhere, basically. And we can do some decoration on an entity that allows us to tell the system, or give the system information about the data store itself. So, you know, what if we want to have a custom table name, or we want to kind of define some of the column properties for that particular property within the entity, then we can do that with data annotations and stuff, and I'll get onto that in a bit. But for now, we're going to talk data. Right. So I'm going to create a folder in here called business. It's business time. Business. I'm going to try and spell it correctly as well. Business. And I'm going to create a folder here called models, because we're going to do some work with models and entities in a second. Okay, right. Now I'm going to create a shared folder, and that's going to be our Kelsoprese shared. If I can actually spell it properly. I've got my keyboard in a slightly off place so I can handle the mic cable being there, which obviously means I can't type anything at all, because that's just how it goes, isn't it? Now I'm going to create a class here called method response, and there is some logic to this. Now, what I like to do when creating methods is have some kind of response that comes back to the thing that's called the method in the first place. I was very happy using void in a lot of methods that, you know, that were fire and forget. If I didn't need to return something, I'll just void it. Doesn't matter. It's off there doing its voided thing. But sometimes it's good to capture what's going on in that method. So maybe I've asked for some data and no data has come back. I've obviously written some code to capture the error in a service that has gone to get the data, but maybe it's not an error. Maybe there just is no data and I want to get a message back to the thing that's called it to let it know that there's no data. So it's a means of communicating information between methods, essentially. This is what this method response, the purpose of this method response class. Now, I'm going to do something which some of you will frown upon me for it, and I wholeheartedly appreciate why you would frown on me for this. You keep seeing all my code. So I'm going to put in two classes in one file, which I know you're not really, you know, you should really be segregating classes. One class, one file, right? But this is basically an overloaded version. There's a method response and an overload for it, which are separate classes, but I'm going to chuck them in the method response file anyway. It's not something I would do regularly, but it kind of feels acceptable to do it in this case because it's just an overload, right? It's just an overload. What harm could there possibly be? So we're going to write the constructor, if I can actually fucking type. Public method response. And we're going to put string message. Bear with me on this because I've got GitHub Copilot installed, which is actually really good, but quite enthusiastic about stuff. Okay, let's just stick the let's stick our public bool message. Now this code's all going to be up in the GitHub, so you don't have to make too many notes. You can go and look at this later on once I've got it uploaded into the public string message, sorry. Public bool error. Yeah. And we'll do our getters and setters in there. Right. So we've got a couple of constructors we're going to put in. Alright. Is that going to let me do it? Yeah, there we go. So we can throw in... it's going to give me a tantrum, probably, so I can simplify that. Convert to a primary constructor. Okay, I'll take that for it. So you're basically saying false by default, and then yeah, okay, that's fine. Tidy that up for me a little bit, and yeah, you've done it, haven't you? You've done it. It's dangerous stuff, this this GitHub thing. Let me just double check to see if that's close to what I actually had before. It kind of is. It's extending it. Do I want to accept that? Do I want to accept that? Because it's usually just extending with a generic data type. I'm going to accept that. I'm going to accept that. And then it's going to complain at me and say something, isn't it? Convert to a primary constructor. Simplify constructors in class method. I don't really want to go too far down a rabbit hole with some of this generated stuff. That is actually... That is a little confusing to read, I feel. I don't know about you. I'm actually not going to use this. I'm going to write this in a way that makes it more easy to read for developers. So I've inherited method response, which means I've already got message and error as part of the method response, or the generic method response object. And I'm going to want some methods that one that just returns the data. Yep. Where data is... No. No, I don't actually like that it's called it data, because I prefer calling it content. Because I think data is a little... It's not always data. It's not always data. Content is going to really not like me doing this, but content equals content. Damn it, man. Okay. Sometimes this corrective stuff gets a little bit excessive. Right. Method response T. If I turn off the app for a minute. I spelled that correctly. Because it needs to be, yeah, and we need to have it as a nullable as well, because sometimes we don't. Public method response, there we go, that's better. And that needs to be a lowercase c. Yeah. Let's do this first, and then we can look at that. And then I've got a method response constructor that allows us to return content and a message, string message. Okay, so you're doing that thing where you're trying to simplify it too much for me, which means I need to declare public string message as a property of this class. Yeah. We'll simplify this, but I want to break it down so you can actually see what it's doing first. Okay, that's better. And then we want to have it as a message and error. So we're going to need to have a boolean, which is public bool error, and we're going to return that bool error to the method. So this is the first thing we're going to put in. And then I want I don't actually want it to return any data if there is an error. So this can jog on. Bool error, and I want to have a message to go with it. String message. And message equals message, and error equals error. So there's a couple of overloads for that class there. So we're returning content. We're returning content with a message. And we're returning an error with a message. And then on this one, we're just returning a message and then true or false as the error. But it defaults to false. So our standard constructor is going to be, well, there's just like just a method. Just a message, sorry. Not a method, a message. There we are. Right. Okay. So that's our method response that we're going to be using to send data backwards and forwards between various methods and services. And that's our proper basic low-level thing that we're going to be using throughout the application, which is why it's in the shared folder. Okay. Now I'm going to create a folder called data. And this is going to handle some of our, well, it's going to handle all of our data interests. We want entities. Entities. So these are what I was saying are going to be our data objects within the application. So we've got method response and we've got our entities. Now I always start with creating a base entity, which if I can find my my example. Let me just check this out. One sec. Trying to find where I put everything. Okay, I certainly can't show you some of this code because this is not out in the wild. Okay, yeah. Yeah, so entity base. Okay, that's our base entity. All other entities will inherit from entity base. And we make that abstract so that we can't create entity base objects on their own. Now, from a component point of view, let's put a little comment above the class just to explain what that is. And then let's put together some IDs and some properties that we're going to share around the application. So we need a key, we need an ID. All objects must have an identifier that is unique to that object. I have a created date because I want to know when the row within that data was created. I have a modified date because I want to know when stuff has been changed. And I'm not going to put it in this one, but often I will add this, which is deleted. So that allows us to do like a soft delete. It's a Boolean flag. So rather than just deleting data from our database, if we don't want it to be accessible by the application, we can set this is deleted flag to true. So as part of our code that comes after this around dealing with repositories and data interactions, we can ignore on all calls unless they're the specific one that will include the, will ignore this flag. All other calls to the data will check to see if this is true, and if it's true, it will not bring the data back in the data set. So that's like a soft delete thing that I do sometimes in some applications. I'm not going to put it in this one because we're going to keep it nice and simple. Nice and simple. As always, this is the first one. How is there an as always? Yeah, any questions on any of that, please ask away. I'll be happy to respond to any of that stuff. So let's talk a bit about this. So entity base, abstract class, which means we can't initialize it as an object of itself, in and of itself, I should say. But all entities, so all data objects, need to inherit the entity base in order to ensure that we have these properties. So the ID, the created date time, and the modified. Now you'll see that there is I'm setting the data on the object creation. So as soon as we create a new entity, they will always have a GUID for the ID and date time now for the created time. And that date time now will be the moment that the object is initialized or created. I use GUIDs for identifiers rather than integers because I like the uniqueness of them. I know there is a potential for there to be two GUIDs of the same value, but that is an incredibly small number, and I'm going to check actually how small, or not my PowerShell, how small is that number. So It is ridiculous. Here we go. Here's a little bit of trivia for you. It's a 128-bit algorithm, and it is unique enough that if 1 billion GUIDs per second were generated for 1 year, the probability of a duplicate will be only 50%. So that's quite low. So I'm going to keep using GUIDs. Because I like them. You know, we have our preferences, and I think a GUID is a suitable identifier for objects within a data set. Yeah, so there you are. It is a very low possibility of getting a duplicate. So we'll stick with GUIDs. So that's our ID. Okay. So all objects inherit entity base. So what do I want to create? This is an accelerator project, ideally. So what data are we going to want to create that's going to be shared across our applications? So what sort of applications do we build normally? What sort of information do we need within our application? There's, let's say maybe we have users. Users are going to be pretty standard. So let's make a class called application user. And, oh man alive, I will talk a bit more about authentication, what's the word? Authorization frameworks, but not today. We're going to keep it nice and simple today. So there's our public class. That's our application user. We put a little colon in. Sorry about that. I knocked the wire out of the microphone. It's a little loose. I need to get another one. So I'm hoping you can still hear me right on that. Why is it not on? Why can't I see? Are you fucking kidding me? Nope. Sorry. Ignore that. Yeah. Sorry. My apologies. I thought something had gone really weird with the stream, but it actually looks... I'm looking at something... I'm using Restream, right? And it was showing me with the main monitor on. Not actually having the view of Visual Studio. And I'm looking at it going, hang on a minute. Like, it is definitely that scene in OBS. I hope. Has it been on the wrong bit all this time? And I've not been showing you anything? Oh my days. For real. I just need to double check this. Sorry everybody. It's a very professional operation, this. Have I seriously not been showing you the stuff? No, I have. It's been working. Okay. Okay, cool. Sorry about that. I just had to double check because that would make the stream even shitter if you couldn't see anything that I was trying to do on Visual Studio. That would be crap. So, yeah. Where was I? I've lost my thread now. Right, entity base. We're making an application user. Right. So this is another entity, but we're going to have, by referencing entity base as the dependency, or it is dependent upon entity base, we will inherit these three properties. So our application user will have an ID, a created, and a modified property because of inheritance, basically. Now I'm going to be really careful not to pull the microphone cable out now when I'm typing, so I'm just going to move the keyboard forwards a little bit and try this. Oh wow, okay. Sorry, I got a bit taken aback by all of the properties it wants to put in. We're going to want a username, right? Oh. Right, I'm going to turn this off because it actually can be a bit of a pain in the butt because I just want to write code. I don't want a million suggestions. Public string. off, off. Right, just let me write code without suggesting everything. Thank you. Username. Gonna need a username. What else are we gonna want? We're gonna want an email address, because that's handy. Gonna need a password. And then I would generally say, are they an administrator flag? Yes or no? Which is all right, but we'll keep that in there for the minute, because we should be creating roles and assigning users to role groups, and the role should have the various permissions. But just for the minute, we're going to just leave that as is. So we've got username, email, password, and then an isadmin. Actually, no, we're not. We'll take that out, because I'll talk about that when I talk about roles later on, in a later episode. Because, yeah, this is just going to be looking at data structure. So username, email, password. That's what we need for our user, right? Not worried about their address. We'll deal with that later. So I want to annotate this a little bit. So we've got some data annotations in there. Now, I have got that. I'm just looking at some examples of stuff that I've prepared earlier, which I've now changed to the chance of a Guid striking a meteor in the face with a ham sandwich. No, where are we? I've lost myself. I've lost myself. Okay. No, I found what I was looking for, so we're okay. There we are. And then I want that one. I can't show you this code because it's a client project. And yeah, you just can't see it, basically. I apologize, but that is what it is. So we're going to put some data annotations in, and we want username is required, and we want email required, and password required. So these are going to impact the data requirements when we build the data set in our database, or whatever we're using, essentially. Okay, so we've got that. That's all looking good. We've built an entity base that is the abstract class for all of our entities, and we've got an application user that inherits from the entity class, and will have ID created and modified properties assigned to it. So that's cool. We've built that bit. So what do we store our data in is the next question. Now, I would create a context, which is going to be essentially our proxy between the thing that stores the data and the application that wants the data, or, you know, sends it back and forth, basically. So context is like a code proxy for data. It mimics the data structure within our data store. And I'm sure you may have found that if you're building database first stuff, sorry, if you're building code first stuff, and you don't update, and you change your entities, but you do not change the data schema within your data store, you will end up in all sorts of problems, because the code, the context, is expecting the data store to look like the entities, and it doesn't. So if I were to say delete the email column from our application user table in a SQL database entity framework, which we'll get onto shortly, the context is going to go, where send us your emails? I'm shutting down. It just doesn't like it. Yeah, it really doesn't like it. So we use migrations, but again, I'm going to talk about migrations later. Let's keep it simple. I'm just throwing these things in there so that you hear the terminology. And if you're developers of some time, you'll know this stuff anyway. I don't need to go into too much detail. So there we are. That's our entity base, our application user. Going to build a context. I'm going to call it application, without pulling the cable out of the mic, application DB context. No, I'm not. I'm not going to call it that at all. I've changed my mind. That's the beauty of code. So simple to change. Don't tell the clients that. Polygon DB context. Yeah, why not? We're using it as an accelerator. We're building on top of it. Now, I want to use Entity Framework for this, and in order to do that, I need to install it via NuGet. So we go into our dependencies, right-click, manage NuGet packages, and we go browse. We find our package, our beautiful package. So I want core version 8, matches .NET version 8. Gonna grab that, and we're gonna get all these dependencies, which is wonderful. We'll take all of that. I'll have that as well. Thank you very much. Well, thank you, Brian. We're not using SQL Server yet, which is what I'm going to get onto later. What I want is the Microsoft.entity.memory one. Framework core. Let's find all of the ones that have that in it, because I can't remember exactly what it's called. InMemory. We're going to install the InMemory database, which, as I said earlier, is the one that basically builds a database, a data store in the RAM, disposes of it when the application shuts down. Nice and easy. Do I need design? If it's going to be relational, which it will be relational, or will it? No, let's leave that out for the minute. We'll talk about relational stuff later. Very well scripted, this. Very well scripted. Okay, so that's installed. We can go to our installed tab, clear that out, and you'll see that we've got EF core and EF core in memory. So I think that's everything that we should need for that. So go back to our context. Yeah. Our context is going to be the thing that interrogates or passes data back and forth between the application and the data store. Okay. Now we're going to want to inherit DB context, which is our Entity Framework core database context class. That's a little black box, so we're not going to know so much about what's inside that unless we crack it open, which you're not going to be doing. So, firstly, let's get our constructor built. We all need to have a constructor. I'm just very conscious of that mic. With some options. DB context options. Polygon DB context options. And then we have base options. I do this thing, and some of my work colleagues notice this, and it makes me laugh. I do this thing sometimes where I start singing the code. So if I do that, just bear with me, because it happens, and I don't seem to have any control over it whatsoever. But, you know, hopefully it's entertaining. He says, try. We love a try catch. Try catch. Base.save changes. So I tend to do a little overload on this, because I want to catch a specific exception rather than just a generic error, which is the DB update exception, not concurrency. DB update exception, which is EX. And then I'm going to capture... I'm going to throw it, but later on we're going to put some logging in and handling of that, because DB update exceptions are a pain in the backside. All exceptions are a pain in the backside, really. EX.message. Nope. There we go. Alright, so that's our save. We also need to get a data set in here. A data set basically translates as a table in a database. So we want an application. Think of it as you're declaring an application user table in your database. Okay. So we've got our application objects, and we want to call it application users, and that is going to become the name of the table. Okay, essentially. Now we've only got application users in there, so that's fine. What is this telling me I should be making this look? Initialize the property from the constructor. No. That is not how I do it. I'm good. I don't like a lot of these prompts. Well, some of the prompts are good, some of them are a pain in the butt, so I'm trying to ignore them. So we've got our DB context. We want to have an interface for that. So I'm going to make an interfaces folder. And I'm going to put an interface in there, funnily enough, called Polygon DB context. I'm going to slap that in there. But I foolishly made a class, so let's make an interface instead. Now I need the DB context to inherit that interface. And I apologize to everybody because I am not doing my interfaces first. But, you know, I'm just trying to explain some stuff, so it kind of helps me to talk about the thing that I'm relating the interface to before I talk about the interface. I guess. Right. Excuse me. Highly unprofessional. Okay, let's look at the stuff in our interface. So we want it to be disposable because we want to drop it out of memory when we're done with it. There's going to be some stuff that we have to have in here that form part of the entity framework DB context. So change tracker. So this checks added modified entities. Okay, so we look at what things are changing within the application. We have this one, which is entry. So that gets the data for a specific entity. And we're using generics here where class is the most, well, it's not the most basic. Object is the most basic, then you have class. But we're presuming that... Oh, actually, I could change that to entity base, couldn't I? Yeah, let's change that to entity base. Because we don't necessarily want all classes, we just want all classes that we know are going to be entities. And if all of our entities inherit from entity base, then we're absolutely fine. Excuse me, sorry everybody. I've got a craggy old throat. Crags. We want this method, which I'm going to paste in, which is returns a dbset instance for access to entities within the repository. Yeah? We'll talk about this as well when I get onto the repository stuff. And then we want the save changes, which is a 0 or a 1. Okay? As an int. And that relates to this. What? Sorry, that was a really weird noise to make. What member's missing? Ah. Okay, I can't do that. Because it needs... DB context just uses class. Alright, let's leave that as class for a minute because I'm presuming that comes out of DB context. We'll clear that out. If you want a shortcut, I'll do that again. A very quick shortcut to order these by name. Order them alphabetically and remove unused namespaces. Hold down Control, press R and then G in Visual Studio, and that reorders and clears out your namespaces. Little keyboard shortcut for you there. Okay. And then what's next? I don't need that. Open the wrong window. So that's our interface for the context. We're then going to do something. We're going to build something called a repository. So repository is a bit like our Git repository. It's a data store. And we're going to have repositories for each type of data, each object, each entity that we're going to call back. But I do it in a slightly... I used to do it where I had a repository for every single entity type. And I would initialize those in the service dependency injection, like the container, service container, and call them in. But I found a different way to do it, and I'd actually be interested to hear your thoughts on that, because I think it streamlines it massively, and it gets rid of all sorts of, you know, additional coding to worry about, and having to write new repositories for new data types as you build the application up. But let me know what you think when we go through this, and yeah, be keen to hear what you think. Okay, so repository. Let's start interface this time, shall we? Let's do it the right way around. If there is such a thing as a right way for anything. iRepository. So this is going to be our repo interface. And again, we need to make sure we're putting a limitation. Okay, so it's iRepository T, where T is any object that inherits from entity base. Okay, and this is where our genericized stuff comes in a little bit. All right, I'm just going to copy and paste the methods I've created already into here so you can see what we're going to go with. Right, first one, get by ID. So this is the GUID ID of an entity. So this gets an object by its GUID. Okay. We want this one. So that's the get available by ID, which uses our soft delete check, but I didn't put that in, did I? So we don't want that one. We have this method. I'm not going to put any of the soft delete stuff in here yet. We can add it later if we want to. Gets a list of all entities of a specific type, regardless of whether they have been soft deleted or not. So that we can delete because we're not worried about that. And we just get an enumerated list of entities back. This one is where we get a little funky. Little funky. This gets a collection of objects based upon a provided expression. Okay, so we can pass. Oh damn! Sorry, I should have turned that off. Right. Oh no, and Steam's coming up as well. Hush Steam. 1 minute. I'm just gonna, just for like, you know, GDPR sake, you can have me back for a second, and I'm gonna just turn off my Steam because everyone's playing Helldivers and it keeps popping up. Obviously, because Helldivers is mad good at the minute. I was playing a little bit before. Oh, why am I opening it again? Why did I close Steam and then open it again? Oh my days. My brain's melting out of my ears. No, don't open Steam. Keep Steam closed, please. Right. Let's go back to main screen. So you shouldn't see any. Right. There we are. Hello again. Right. So there's our get methods, right? So we can. This lets us pass lambda expressions in to a get, so we can really fine tune the entities that we're getting out based on various different factors. Okay. Then we have. Right, I put this one in. This is a recent addition to the repository interface because I was having some issues with something. So this gets a collection of untracked objects. Now, tracking is really useful because it means that we can keep an eye when we get a list of objects out of the data store. We can keep an eye on what we're doing with those objects, and we can track them to see if they are changed or not before we store them back in the database. Now, I had an issue where there's a particular use case where I had to get a small subset of data from the data store and compare it against what essentially was the same list but modified by the user, and then check some of the do some comparison work to check what the user had changed, which would then trigger other things in the program. But because it was all tracked, Entity Framework was having absolutely none of it when I tried to do an update. So I used get untracked to get my list of data, my virgin untouched data from the data store, and then I left the tracked data on the stuff that the user had modified, so I could then do a comparison between the two. So that's the untracked stuff. It comes in useful occasionally, so I'm leaving that. I'm going to leave that in there. We've got a delete. We've got a delete method. Oh no, sorry, I can't read that, can I? What's wrong with my eyes? I've gone blind. Bool exists. That checks to see if something exists, but there isn't any link expression for that, so I can probably get rid of that in hindsight. I wrote this a few years ago, this whole thing, so clearly without having enough coffee, but I can just use the get with the .any. I don't need exists at all. That's pointless. We're going to get rid of that. Let's streamline it while we're here. Right, add. Add is obvious, isn't it? We're going to add something to our data store. And then we have this one, which is quite useful. And that is add an enumerated list. So that basically we can add one object, one entity. We can add a whole list of entities at once. So that's what those are about. And then we have update. That updates a single entity. And I should probably... That's interesting. It's funny looking back over stuff you've done previously. I've not got a batch update. I've got a batch add and a batch delete, but not a batch update. So that will probably save me some data transactions on my database if I numerable T entities. Okay, well that's cool. We can add that in. I'll write the code for that in a minute. And then we have delete and an enumerable delete. So, and if I keep it in the same vein as the others, then we'll have the single and the enumerable. After the enumerable, why have I got 3? Deletes a specific entity. Deletes an enumerated list. Oh, that's a soft delete one. Yeah, we don't want soft delete anymore. We're going to leave that out. Okay, so this updates, batch updates, a list, entities. There we are. What does it return? Yay or nay, I think. Right, so there's our interface. That is our repository. I've probably got some spelling wrong there as well. And that wants it to be lowercase, doesn't it? What's powering that? Language tool. Okay. I'll lowercase that. Because the parameter's lowercase. That's why your parameters are wrong, sir. There's our interface. We now need to make a class that's going to be our concrete object, which inherits our interface. And that's going to be our repository class. And we're only going to make one of these. Here's our repository. Wonderful. Right, and that's going to inherit iRepository. Let me find my code. I need to do something else first. We'll get the inheritance in. And I want to make this a sealed class so you can't inherit from this afterwards. There is no inheritance from this, if you please. And then we just want to make implement the missing members. That would just give us a thrown not implemented exception. So the reason we do the repositories first is we think about the different methods that we're going to need in our class. We haven't got to build anything. We just think, well, what do we want our class to do? What methods do we want it to contain? So we write the interface, and that defines what the methods are, what's going to go into it, what's going to come out of those methods. If we then create the class and we inherit the interface, we get that nice little thing come up in Visual Studio that says, do you want me to make all these methods for you? Or scaffold the methods. So you can see here we've got all of our methods scaffolded with a not implemented exception. So you should always make changes to your interface first and then come back and do your class afterwards, because the interface is what the rest of the application sees. The application doesn't see the repository. This is stuff that happens behind the scenes from, you know, the rest of the code's point of view. It's the interface. The interface is the stuff that's interacting with your other methods. So interface first, class second, as a rule of thumb. I mean, it's not like, you know what I mean. It's not like no one's going to crucify you if you don't do it, but it just helps, you know, reduce the amount of mistakes you're making, basically, or you could make, I should say. Right, next, as I said, any questions, please ask. I'm happy to, you can either ask them in the live chat, or you can ask them as comments once this has gone out, or is going out, but you know what I mean. You can ask future me questions, and I will look upon past me and smile more mournfully at the mistakes that he made here. So yeah, just ask me questions. Ask me questions. It's all good. Where was I? What was I doing? I was going off on a tangent, wasn't I? Right. Okay, I can't implement this because I'm missing something, and this is the key part that I mentioned earlier. I'd like your opinion on. Because, yeah, just because it feels like it streamlines everything, and I've used it on a few projects and it has worked really well, but you can tell me if architecturally there is a dirty stink around this. I don't feel like there is, but I will be interested to hear your thoughts on it. So yeah, unit of work. Some of you are gonna throw your chairs at me or the sink or whatever for doing this, but I like a unit of work, and I like the unit of work because it acts as a holding pattern between the data changes in memory and then storing them in the actual data store themselves. So I'm a bit of a fan of it, and I use it, not in an overcomplicated way, but it just helps manage data in a safer way, I feel. And again, that's an opinion. By all means disagree. I'm happy for people to disagree. I'm happy to hear why people disagree, more importantly, because I think it's good to share wisdom and ideas around this stuff, because, you know, there may be something I'm missing. I just know from my experience, which is all I've got, that pattern using unit of work has served me well in a number of applications that I've built. So yeah. Anyway, share your thoughts on that if you so wish. I will be keen to hear them. So that's our interface. We've got the context, which is our data proxy. We've got this get repository method, and we've got the commit, and the commit is the thing that saves the changes. So once you've done all of your data manipulation, you hit commit, and then that saves those changes into the data store. Before that, it keeps it all in memory. So it can be good if you're doing a lot of work with different repositories and managing lots of data. You can do all the stuff in memory and then fire the changes into the data store at the end, which saves on database transactions, but you're going to have to offset that against the amount of memory that your application is going to use, because if there's a lot of data, it's going to obviously chew up a lot of memory. So it's an offset, speed versus memory versus data transactions on that one. Right, let's make our unit of work. Make our unit of work. Unit of work. Did that need to have a dispose on it or not? The interface. Did it have a dispose? It did have a dispose. I should dispose my interfaces that I don't. There we are. iDisposable. And have that as disposable. I'm going to save that. Unit of work. Inherit our unit of work. There you are. And it very kindly gives us a namespace. We hit control and full stop, and we can generate the missing members. There we go. Fabulous. Right. Let's make the concrete. Let's do the class. Make the concrete. Do the class. Right. Now, bear with me on this. This is where it gets a little funky. I create a dictionary. You're like, what the hell are you creating a dictionary for in unit of work? It's my repository dictionary. Okay. My constructor. Where's my constructor? So when I build the unit of work, when I initialize it, Polygon, the application context. What's that telling me it can do? Yeah, okay. I'm not worried about that yet. I've got the context. I've got the repository. Right. Now this, what is not happy about this? Project has 0 parameters but is invoked with 1 argument. Oh, cheeky. Cheeky, cheeky. What is going on here? Let me fix this first. I may have to bring in... I may have to do something in the iRepository. Ah, no, because I'm calling the concrete, aren't I? And I haven't added it in yet. Okay, that's me being a fool. So I need to initialize. I need to put my constructor in the repository. There we go. Convert to a primary constructor. Yeah, I don't like that though. I kind of like seeing the constructor in situ. Just feels like it's easier to read. I get like some of these simplifications, like they make sense. But I, you know, kind of just like seeing that constructor because I keeps it clear and defined in my head a little bit. So now we should be good. We shouldn't be complaining, yeah. So we're passing the unit of work into the repository class and we're adding the repository to the repository dictionary. I'm going to show you this, how this works in situ, but fundamentally, rather than us creating a separate iRepository class for, sorry, a separate iRepository for every single entity type in our service container, we can just call the repositories within the constructor of the class where we need them via this whole unit of work iRepository method or get repository method. Like I say, it seems to work pretty well in stuff that I've used it in before. But yeah, comments and thoughts always welcome. So I've got my commit. My commit should return context save changes because that is saving the data into the context. And we want to dispose of our context when we are done. And I'm going to put that at the bottom because I kind of don't think that should be right at the front bit there. There we go. It's a little tidier. Nice. Okay. What's that got to say? Change it to GC suppress finalize object. Just prevent derived types. Oops. This will prevent derived types that introduce a finalizer from needing to re-implement iDisposable to call it. Yeah. I'm alright, because I just kind of want to dispose of the context when I'm done, so... Yep. Just going to leave that. Just going to leave that right there. Don't worry about it. It's going to be fine. Don't you worry. Yeah. It's going to be fine. Right, let's do our repository, yeah? So we've got our unit of work now we can start building our repositories. So, get by ID. All down to the unit of work. Because we're getting the context from the unit of work. There's a... Oh, cat's calling me. What do you want, little miss? Where are you hiding? She's around somewhere. I can hear her. What's the matter? Where are you hiding? She has been fed, so I'm presuming she's alright for the minute, but I don't know where she's gone. She'll make an appearance soon. Let's fix that possible null. What did that change? I don't really want that as a... Okay, I'm going to leave that. We're going to come back to this because this code is a couple of years old now, and it could do with a rework. Get all. So that doesn't need the X is deleted because that's not actually. Oh no! My apologies. I've got the wrong bit of code because I'm pulling it out of the. Yeah, so we just want an enumerable list. That's it, of a particular data set. So that will get. So if I did I don't know, application user repository dot get all, that would get all of the data for all of my users out of the table of the data store, essentially. This one, with our expression, will only get our application users that meet a specific criteria that we define in our where clause. And I shouldn't be returning that as a list. That should just be enumerable, and I should list it when I'm finished. So adding toList terminates the data connection. If you have it as an as enumerable, the data connection remains open, because there may be more interrogation work that you need to do once you've got an enumerated list. But if you dot toList at the end, that will terminate your data reader. Essentially, you may see this if you try and make multiple calls for different data sets in a method, and you're using something like SQL, Microsoft SQL, just storage data store. If you have as enumerable for both, and you don't list the first one, then it will go cannot connect SQL data reader already in use or something like that. So when you're done getting data, to list it, and that locks it, puts it in memory, frees up the SQL data reader for you to go and make another call if you need more data. Okay, so just a little something to remember if you are doing any sort of data interaction stuff. This is our get untracked, which has just this extra parameter here, which is as no tracking. And again, I would have done that because I wanted to make sure that I locked, I closed the data connection when I was finished. But I guarantee you I've put toList in the methods that are calling this, because I'll be thinking I have to close the data connector. Delete. No. We don't need exists. Here we are. If we add a null entity, have a tantrum, otherwise we're good. And then this is basically a wrapper for the add entity. Let's just tidy that up. I'm gonna just put some brackets in to make this a little. This is gonna go. You can do it as a single statement. I don't like these. Use argument null exception. Throw if null instead of explicitly throwing a new exception. Show me what that looks like. And then you're going to show me something else that I can do. Is that right? Yeah, I mean, that's tidy. I'll take that. That's good. What's next? We've got an update. Okay. No. Yeah. Okay, so I'm not. So this is our unit of work bit that's going to update. But I need to make sure I've got my parameters named correctly. Let's do that. Let's just throw this. If we're putting in, if for any reason we end up throwing a null object into this, we can fail gracefully. We always want to fail gracefully if we can. And then we're going to want to take this and change that to update. So that's our update enumerated list method. And then we have a delete. So we just want to do the whole context thing now. And again, I'm going to chuck in the, make sure we name those parameters correctly. And then we're going to throw in the entity to delete argument exception. And then it's going to be the delete collection, which is somewhere here. Oh, hang on a minute. Hang on a minute. I've done something slightly different. I mean, it's good different. It's good different. So that's the delete entity. I can delete by passing a specific entity, but I also can delete by an ID. But that's not in the it's not in the interface, is it? Did I not include that in the interface? Oh, look at that, I didn't. So we're going to want to delete an entity by an ID. So this deletes a specific, nope. Deletes a, oh my days. Where's the L? There it is. A specific entity by its ID. Okay. Yeah, that's better. Right, so that's our interface finished. That's our class finished. Yeah, so we don't want to have to get the whole entity, do we, to delete it? Sometimes we just want to delete it by the ID. And do you know what? Let's do a delete by a list of IDs. Let's do an enumerated one as well. And then we just go for each. Oh no, I need to do this, don't I? So it's an IEnumerable string. And then I need to turn them into an array. Equals I. Do I need to? Yeah, probably do need to. As. Well, do I? No, I don't. I don't, because I'm. No, there's a thing around arrays and enumerables. I don't need to do that. So I actually just want for each var ID in IDs. She's crying at me again. Oh, there you are. Hello. Did you get stuck? What's the matter? Hmm? Did you get stuck? You too big to get through the crack in the door? Chunky monkey, come here. Hello, you. Hello, Bubba. We're having a cat break. We're just having a cat break. Just one. Just a minute. Just a minute. Oh, lovely. Where you been? Where you been hiding? Sleeping. Okay. Right. Delete ID. There we are. And then that should give us a enumerable delete with IDs. So that's going to make that a little better as well. There we go. Deletes a list of entities by their IDs. Cool. If you are not familiar with comments and interfaces in Visual Studio and .NET, only comment your interface methods. Because what happens is when you hover over the method like this, as you see, it gives you a description of what it does. So if you're calling this, so later on, once we've packaged this up as like a NuGet and a GitHub package, when you call these methods, they're going to be wrapped up in that package. So it's like a black box. You hover over these methods, it's going to give you the instructions that you've put in your XML comments. So XML comments are important. Very, very useful to have. You can see some another example there. So that takes our summary and explains. If I put the explanation of the parameters in there as well, it'll probably tell us that. See, look, gets an entity by its ID, returns entity. So it gives us the return stuff as well. Yeah, so XML comments, really useful. Very good to be decorating your interfaces with XML comments. Right, I think that's everything. Let me just do a quick build, see if it actually builds it. I've not balked it all. Build started. Build succeeded. That's a good sign. That's a good sign. Okay, so next. We need to bring that into our startup, don't we? So here's our program. Here's our program. We're going to need to do some dependency injection. So we have to declare our services. We have to map our interfaces to our services inside the service container. Now, thankfully, you can do this straight out of the box with .NET 8. I think we could do it in .NET 6. I've certainly done it in earlier versions as well. You haven't got to worry about like an IOC or using simple inject or any kind of third-party like autofac, I think is the other one, isn't it? You haven't got to worry about any of that. Do it all in your program class. Absolutely wonderful. It's a really big improvement that I'm a huge advocate of. Is the way that dependency injection is handled in .NET Core. So much better. Okay, so I need to get access to the services. So I go app.services dot let me just double check how I've done this. Add scoped. No. Is it dot collection? Is it app.build? Where have I put it? Where have I put it? Services dot. Surely. Services dot ads. No. Oh, I've been flummoxed. I'm sure that was how I did it. Yes, Bubba. What's up? You want some fuss now? There we go. Oh man, alive. Right, let me just double check this because I've clearly forgotten how to call these in the just raving on about how good this is. Add services in program.cs. I should check this. DI in .NET Core. Right. Sorry everybody. It's builder.services.addScoped. Yeah, not app. There we are. That's better. Okay, so we're going to start scoping our services in. So we start with the DB context. So Polygon DB context. And we want to map that to Polygon DB context. No. Yeah, call that in. Right. Yes. Why you put the little star there? Because I pressed the wrong button. Right, good stuff. Next, we want to map the iRepository. No, we don't. We don't map the iRepository. That's the point. We map the iUnit of work against the unit of work. Okay. So we've mapped that, and I will explain why we don't map the iRepository in a second. Because we can actually build that as we construct it. Maybe I can get around this actually. Maybe this is a more elegant way to do it. Just thinking on the fly here. iRepository, application user. Import that. Yep. Come on. It's going to map to repository, application user. So that should do us. And then we just have to DI that into... No, we don't. We don't, do we? Because that's... No, okay, let me leave that out for a minute and I'll explain a bit more around that shortly. Okay, so I need to add in a data store. So we're going to add the DB context into this. I'm actually going to put the app after because that's... So if you're familiar with .NET 6 and prior, this is sort of where your startup kind of would go. So you'd have two methods in your startup class. One of them would be configure, and one of them would be configure services. So this is going to be like the configure services section, and then this bit below is going to kind of be the configure section. So we build up all our services, and then we configure how the application sort of behaves and does stuff afterwards. Okay, so let's I like to try and put this as high up the list as possible just because it makes me feel more comfortable. Data initialization, and I'm English, so I'm going to spell that with an S, not a Z. Not that it matters, it's all the same, much of a muchness. So I want to go services, builder.services, add DB context, Polygon DB context. And then I'm going to give it some options. And I think it's the curly brackets, curly. It is the curly brackets. God, I'm not even checking the chat. Not that anyone's talking to me on here. There you are. No questions yet, but we'll save them for the comments. It's all good. And then options. Use in-memory database. And if I remember rightly, this is the database name. And I normally just put new. Now, is it GUID.NewGUID? How have I done it in the entity base? So you know what? No matter how long you do this for, you will never remember everything, and that's okay. Right now, you can give it a static. So there's a using memory database. We've got this parameter string database name, right? And you can give it a flat string, a static string value. But I remember doing that previously and running into some conflicts where it tried to initialize the database with the same name, but there was something like it complained about it existing already, or it hadn't flushed it out of the memory quick enough, or something like that. So I went with GUID.NewGUID, which makes a random GUID. And then obviously convert it to a string because you want to use a string, not a GUID, as a database name. That guarantees you're never going to get any conflict ever with your database names, because it should, in theory, clear the database out of the memory. You can use the same name again. But I can't remember why. I did get an error years ago, so it probably works fine now. But I just use a new GUID for the database name. It doesn't really matter. It's just what it stores in the DB. If I were to have two contexts and I were to call them the same name, so if I had another one of these underneath and I had a different context for a different data store, and they both had the same name, then it would have a meltdown because you've got two in-memory databases with the same name, so you're going to have a massive conflict. So just using a GUID, it feels like it solves a few problems. It saves headache down the line, basically. You know, always think of your future self when you're coding, and be kind to your future self. Don't cut too many corners and just think I'll do that later, because you don't. You never do it later. Technical debt builds up like a pile of shit very fast. So try to keep your technical debt to a minimum where you can. That's all I'll say. Speaking from experience, definitely. Right, so let's enable some detailed logging and stuff as well. What you can do, I'm going to put this in just to show you, because this is kind of useful. So you probably come across preprocessor statements before. They're not written like that. I need to find the hash key. If debug. So if we're running it in debug mode, it will use these additional statements, which is enable sensitive data logging and enable detailed errors. If we are running this in production, it will not. The application should not be in debug mode. It should be in. It should be on release on this version. Yeah. But because we're in debug mode, it will run. If I go to release mode, you'll see that will grey out. So we aren't going to run this bit of code. So we go debug. So when we are debugging it locally, we can see, you know, more sensitive data logging, and we get more detailed errors. So that is something to put in if you are, yeah, just to make your life easier. And you don't have to worry about taking it out of the code when you release to live or production. It just switches off automatically. So preprocessor statements can be useful when it comes to changing like your logging values and the data you're outputting to the console, that kind of thing. So just bear that in mind. Bear that in mind going forwards. Now, this might work. This might actually work. Let's. If I fire this up, I should get an index. Web browser, Firefox. Shall we hit play? See what happens. What's it gonna do? What's it gonna do? Holy moly. Look at that. It's working. Isn't that glorious? Nice standard bootstrap framework. Okay, so that's it. That's our data layer built nice and basic. You can see we've got some output here. This console, if you start doing data transactions, you'll see the console will fill up because we've got sensitive data logging and detailed errors. You will see that everything you do will be logged here, which can be handy. But yeah, you don't want to see that on a production environment, so turning that off is very useful. And we're only using 72 megs. Look at that. How glorious. So that's our basic application. We can close that and it will shut the application down. Yeah, I'm going to park that for tonight. It's been 2 hours, and I think that's long enough for going through a little bit of code. I will commit these changes to the repository on GitHub, and I will paste that in chat again, so you've got access to that if you want to have it. There were some links to other stuff as well that I talked about at the beginning of the video, but or stream, I should say, and I'll put all of that in the details in the comments of the video once this has gone offline, once I've gone offline, and we can update that stuff. I've lost my restream window. Where's my restream window? Oh, because I'm looking at the wrong thing. There we are. Okay. I've lost it. I've lost it. Where is it? Oh my days! This is professional stuff. This is, ladies and gentlemen, professional stuff. I can do it in OBS, can't I? There we go. Right. That's the repo. You should be able to pull that down. once I've uploaded these changes to the develop branch. And remember, the develop branch is where we are doing all of our code. We do not work in main, because that should be a reflection of our production or live release environment. I say live, you know, this isn't going live, but it's going to be a class library. So there we are. Okay. Any questions about any of that? Drop a comment in the video, and I will answer them as soon as I can. Any thoughts and ideas, equally happy to talk about those as well. So yes, throw questions and comments in the appropriate section on whatever platform you find this on. I think we're on Twitter, YouTube, and Twitch with this stuff. So go find us. Right, let's go back to the main. Let's go back to full screen mode. Full screen. There we are. Okay, well, I'm hoping that's been of some interest and it's been of some use, and you're able to glean some things out of it. I'm going to be carrying on with these streams. The next live one will be next week, but I will endeavour to try and record some other stuff around this later this week as well, so you've got a bit more to work with. But there's your basic .NET application, .NET 8 application with a data layer, an in-memory database, and some entities that you can play around with. So yeah, nice and straightforward. And I'm hopefully, if you've worked in .NET and you've worked with .NET Framework, like 4. Up to 4.8.x, whatever the version is, 8.2, whatever it is now, compared to .NET 8, which is the whole cross-platform .core stuff, it's just light years ahead. It really is. Its simplicity and functionality are so much better. So yeah, hopefully you can get that or glean that from the content we've talked about this evening. Anyway, I'm gonna go and have a coffee and play some Helldivers 2, because it's really good. It's dangerously good, that game. Hope you all have a wonderful evening, a wonderful rest of your week, and look out for some future videos where we will be expanding on this Polygon project and talking a bit more about turning it into something that you can actually use in your own applications. Take care, everybody. I'll catch you soon.